Our next session is Understanding Genetic Kidney Disease Insights into APOL-1 Gene. This next session, we are pleased to have Dr. Josiah Peterson, Associate Medical Director in Clinical Development and Translational Medicine at Vertex Pharmaceuticals. Once again, big ups, big thank you to our gold sponsor for this session, Vertex. Let's give a warm welcome for Dr. Josiah.
Good morning, everybody. How is everyone doing? Wonderful. Let's see. Are the slides up somewhere? Oh, okay. Can you guys hear me okay? Cool. Thank you all so much for having us. Thank you for putting this on, and this is a real treat for me to get out of the office in Boston, actually, to somewhere slightly warmer, but not much warmer. My name is Josiah. I am a pediatrician by training. I now work at Vertex Pharmaceuticals in our clinical trials division. I work on different disease than the disease we're talking about today, but Vertex Pharmaceuticals is a global biotechnology company. We use science and innovation to try to address very serious diseases for the patients that need them. We work on things like cystic fibrosis, sickle cell anemia, and a number of different kinds of kidney disease, one of which I'm going to talk to you about today. My hope is at the end of this talk, you understand at least this one kind of genetic kidney disease, what your risk is, family members' risk, and your community's risk is, and what you can do about it. So with that, today we're going to talk about kidneys, kidney function, kidney disease, overall kidney disease burden, and then we're going to talk about this gene. It's called APOL-1. APOL-1 is a gene that can cause certain kinds of kidney disease. We call it APOL-1-mediated kidney disease. And we'll talk about genetic testing, what all that means, and how that affects you. So let's start with talking about the kidneys, just generally. So your kidneys are these two kidney bean-shaped organs. They're about the size of your fist. They sit right in the sort of small of your back on both sides, right where your lower ribs are. And the purpose of the kidneys is that they have a couple different functions, but their main function is to filter your blood. And so that that filter gets rid of all of the waste that you don't want and keeps in all the good stuff that you do want. The kind of filter in your kidney is very tiny, it's a sort of microscopic thing called a nephron. That's the unit that filters. It's sort of shown here. The blood goes into this one sort of circular part here called the glomerulus. This glomerulus is really the sort of main first part of the filter. As all of the blood goes through the tubule, the second part of the nephron, all of the stuff that you want to keep in your body gets reabsorbed back into your blood, and all of the waste goes out the rest of the tubule and gets excreted as waste in the form of urine. So that's what the kidneys do. When that kidney is working well, that means things that you want to keep in your body, like protein, certain molecules, those things stay. And that ends up on this side, that's represented by these purple circles on the blood side, through the filter, and then these sort of green circles are the excess fluid and waste that your body is trying to get rid of, and that goes out. But when you have a damaged kidney, either from disease or certain infections or all kinds of things can cause a damaged kidney, that function begins to not work anymore. That filter doesn't work as well as it should. Things that should be leaving your body, like excess fluid, it stays in the blood, and things that you want to keep, like protein or albumin, starts to go out the other way. And so when you think about, I'm sure people in here maybe know someone who's on dialysis or has needed a kidney transplant. Those dialysis machines just do this. They just filter and keep things in and keep things out. That's really all that dialysis does. And it's a really important function. Without it, your body's just unable to function. So I'm going to point out two things. One is this word glomerular function. I said the glomerulus on that previous slide is that first filter. Your glomerular function is what we kind of call overall that filter function. And that's going to come back later when we talk about what tests you need in order to look at your function. And then the other is protein in the urine. Remember, we want to keep protein in our body and not let it go. And so proteinuria is protein in the urine. And so your doctor can look for protein in the urine to kind of measure how well your kidneys are functioning or not functioning. And we'll come back to some of those tests later when we talk about how to check for your kidney function. So a lot of people in the US and around the world have chronic kidney disease. So 1 in 7 Americans, or 37 million Americans approximately, have chronic kidney disease or some form of it, which is a lot of people. The interesting thing, or one of the interesting things about it, is that many of those people don't actually realize they have chronic kidney disease. 9 out of 10 of those people don't know that their kidneys aren't functioning the way they should be. That's because the symptoms of kidney disease are very subtle, and we'll talk more about them. But you don't really start to see kidney disease symptoms until your kidney function is very low. I'm talking about half of what it would be normally, or even lower. Into moderate, even into sort of severe kidney disease is when the symptoms start showing up. And that's important because you need to start looking for signs and symptoms of kidney disease early. You need to think about it before the symptoms show up, which means you need to ask your doctor, check on your body, all of those things before the symptoms show up. Because once the symptoms show up, that means your kidney function is actually already very, very low. Kidney disease is very expensive. We say about $124 billion is spent on kidney disease every year, just for Medicare and Medicaid. 37 of that is very end-stage renal disease. When your disease is very severe, you might need a kidney transplant, you might need to be on dialysis. And then another 87 million is just generally taking care of people with chronic kidney disease before it even gets that bad. And we put up these numbers because it gives us a nice measure. It's easy to count dollars. It's a very simple way to know how bad the burden is of kidney disease. What it doesn't tell you, and what I hope you take away, is that that's not the only thing that matters. Every hour that someone spends in a dialysis chair is an hour that they aren't at school or aren't at work or spending time with their family, doing the things they want to do. There is a huge burden of kidney disease when you're tired and exhausted that goes along with it that has nothing to do with the dollar amounts, but it does give us a sense of how big of a problem it is. And I hope that this slide sort of helps make that point come home. And I think this room and this audience is very well versed in what I'm about to talk about now, so I don't need to belabor the point. But kidney disease affects certain populations in this country much more than others. If you look at this sort of purple line at the bottom here, so this is the incidence of kidney failure over the last 20 years or so, up to 2019. This is number per million people. So for white Americans, around 250 million people in this country every year end up with end-stage renal disease. Asian Americans are here, Native American and Hispanic Americans are here, and then Black and African Americans are way up here, about 4 times as high. And even though the incidence is coming down, still way too high above what our other counterparts in this country see. This is a huge problem, obviously. We are 13% of the population in America. We are 35% of the kidney disease. That disproportion is a problem. There are a number of reasons for that. Again, I don't need to explain that to this audience. Cost, access, all of those things. Those are big reasons for this disparity. One additional reason, or one additional factor that we're beginning to understand more about, is our genetics and the genes that play a role in kidney disease. And so I don't want anyone to come away from this thinking that genetic kidney disease is the only reason that Black Americans have higher rates of kidney disease, but it is a reason, or we're beginning to understand a part of the reason why that might be the case as well. So let's talk about genes and genetics for just a second. So your genes are those factors in your DNA that your parents passed down to you and passed down to all of us that are your characteristics. They're your eye color, they're your height, hair color, all of those things. Of course, there are variants. That's why we're all different. Genes also play a role not only in our physical characteristics, but our disease risk. And so everyone has variations in their genes that will also create variations in the risk for any given disease: blood pressure, cancer, kidney disease, all of these things. And it's not always a yes or no kind of answer. It's just a sort of variation in the risk of disease. So back in 2010, which is 15 years ago, which in some ways feels like a long time ago, but in medical terms is actually kind of recent, they realized that one of the genes that everyone has, APOL-1, has a number of variants in it. And those variants can cause a higher risk of kidney disease. And those variants exist in some populations more than others, and we'll talk about why that is. But those variants, we call them risk variants, get passed down from your parents. And so if you have 2 parents, one who has a sort of common gene, the regular gene, that has no risk, and then the purple one, which is the higher risk gene. If they pass, as they pass these genes down to their children, you'll have some children that have no risk because they just get the very common variants. You'll have some children that get both genes, and those are sort of in between, or in this case, actually, we think low risk. But there's going to be some children, just by chance, who end up with very high risk before they've shown up in the world, before the environment gets to them, before they ever, just live at all. They have a higher risk at baseline for kidney disease. So the question is, one question is, where do these variants come from, and who has them, and why do they have them? So if you think back a couple centuries, couple thousand years ago, in sub-Saharan Africa, there is a parasite. It's called trypanosoma. It causes a disease called African sleeping sickness, or trypanosomiasis. It can be a pretty severe disease, and it can be a big problem in those settings. And so some of these variants, so if you are a person who turns out that this gene plays a role in protecting people against the parasite, or that specific parasite. For people who have the sort of baseline normal gene, there's not really any extra protection against the parasite. It's just sort of standard, and it can infect you, and it can be a problem. For people who actually get two of the variants, so G1 and G2, we're calling G0 the sort of basic one, the sort of normal one. Basic's probably not the right word for it, but you get my point. G1 and G2 are the sort of risky ones. So if you have a normal one and then one of the risk variants, G1 or G2, you get this sort of protection, extra protection against this parasite, which can be a good thing. And you don't get an increased risk of kidney disease with these if you have both. But if you're someone who, again, just by chance is that little child, gets two of the risk variants at the same time, you get really great protection against this parasite in that setting, but you also get a higher risk of kidney disease. We find that this variant actually attacks the kidneys when they shouldn't be doing that, even though the parasite is not there anymore. So a gene that was very protective and useful in one context is no longer useful in that context here, and confers worsening risk of kidney disease because this gene, for whatever reason, also attacks the kidneys. If anyone here is familiar with sickle cell disease and malaria, and how in some settings it can be actually protective, if you have one copy of the sickle cell gene, but two copies can actually make you very sick, it's actually very similar. That sort of one copy can actually be protective against malaria. If anyone's familiar with that story, it's actually a very similar story for this. So that means the people who have now, in this context, these risk variants are people who came from sub-Saharan Africa. And so you'll find these people both there and wherever people with sub-Saharan African ancestry came from or live now, either because of current migration patterns or more commonly or more historically forced migration through the slave trade. So places like the United States, the Caribbean, Latin America, Britain, the UK, all of those places where Black people were moved or moved voluntarily. Those are the people who have these risk variants. So that's mostly, in this context, Black Americans is one thing to think about. That's also Latino Americans who can have African ancestry. That can be some white presenting Americans who have African ancestry. So don't think Black disease, think gene, but anyone with recent African ancestry is going to be at higher risk of having these genes. And this lower number here, I just want to point it out. It's 13 out of 100 Americans, Black Americans, have two copies. So I want you to think about how many people are in this room right now. I'm bad at counting, but let's say there's 200 people, 300 people in this room. That's 40 to 50 people. 20 to 30 people in this room probably have two copies. Think about your churches, think about your sorority chapters. How many people are in those? If there's 100, 13 of those people are at this high risk. And I don't say that to scare you or to be sort of worrisome. I say that to say you can be aware of it and be empowered to do something about it and talk to your friends and family members about this higher risk. The other thing to say is that just because you have both these copies does not mean you will get severe kidney disease or chronic kidney disease. It puts you at higher risk. And so a second hit or sort of another factor when you have this underlying gene means, or what can cause worsening kidney disease. So for example, if you have high blood pressure, that can cause kidney disease. If you have high blood pressure with this, you'll have worse kidney disease or higher risk of kidney disease. If you have COVID by itself can cause kidney disease. If you have COVID with this, you have a much higher risk of getting chronic kidney disease. So it's a risk factor. It is not the only factor, but it's a very important one. So we kind of group a number of those diseases: hypertension-associated kidney disease, lupus nephritis. Lupus, if you've heard of, can cause kidney disease. Some certain infections like HIV and COVID can cause kidney disease. We kind of group all of those under the sort of same umbrella of APOL-1 mediated kidney disease, or AMKD. It is rapidly progressive. It is often presents sort of younger than typical kidney disease shows up. So, if the average age of kidney disease is sort of closer to like your 50s and 60s, you might see it in closer to like 30s and 40s, and otherwise like relatively healthy people. And I'm bringing up an example of that later. So I said we're going to talk about some of the symptoms of kidney disease, and I want to make sure that we have time for questions. So they're very subtle. These are not obvious symptoms. They're fatigue. Who's not tired? I'm tired all the time. But very sort of chronic fatigue, where it's like you're not really sure why. You've been tired for a lot longer than you normally are. That's a problem. That's a thing you should think about. Swelling in the legs and feet in particular. So, all this excess fluid that your kidneys should be getting rid of, that's not happening anymore. Now it gets into your feet, into your legs, starting to gain some weight. Maybe this summer or this spring, finally get to bring out those shoes that you had to put away 6 months ago, and suddenly they're not fitting quite the way they used to. That's a little weird. Like, why is that happening? So, the weight gain, and then the protein in the urine that can happen with kidney disease can create sort of a foamy nature to your urine. This is probably one of the more weirder kind of symptoms, but you might notice in your urine it's foamier than it should be and like very bubbly, and that's kind of typical. So if you have a bunch of these symptoms going on, it's something to think about. It's something you should get checked out with your doctor. It's very silent again, and they don't really show up until the kidney disease is sort of severe. So what testing is there to do for this kind of kidney disease? So the first two, looking for the protein in your urine. That's a thing they can do in your doctor's office. You pee in a cup, they check your urine. They can tell pretty quickly if there's protein. If there is, they need to do some more testing. The EGFR, I remember I said that the glomerulus from earlier, that sort of filter, the glomerular function. So the EGFR is a glomerular filtration rate. This is a blood test, and it's actually a very common blood test. It's sort of a standard panel thing that they do. If you've gotten blood work done at the doctor's office, they've almost definitely done this test, and so they have some sense of it. So you might actually, if you're starting to have some symptoms, you might be able to go say, I want this test, but could you look back to see if I've had any other issues in the past? Because you've probably already had it done before, if we're being honest. Then the third test is this genetic testing. This is the testing for the gene itself. So these will tell you about your kidney function and just sort of generally how your kidneys are. But if you have any sort of abnormalities and you have one of these genes or two of these genes, then we're starting to think about the genetic form of that kidney disease. Lots of kidney diseases can cause these two symptoms, but we're talking about the genetic form if you have these two variants. So we'll talk about genetic testing quickly. So genetic testing is important. It can test for those risk variants. It will help you understand the cause. If you have these variants, it can tell you a lot about the cause of it, what may be causing your kidney disease, and also how quickly it might progress, what it might look like, and what your disease would look like if you have this. It allows you to be very proactive about your health. You can think about your community and your family members who might have kidney disease, and you begin to think about whether or not they should also be getting tested. And it also allows for, now that we understand these genes a little more in these kidney diseases, we're doing a lot of clinical trials to create medicines to help. And if you have these genes, you'd be eligible potentially for clinical trials to find new medicines and treatments that we're working on. So the testing for genetics, it's not quite as simple as the sort of urine or blood tests you normally do. These are either a cheek swab, sort of like you get saliva from your cheek, or another blood test. You would talk to your doctor about it. There's a little bit more information that needs to go along with the genetic testing. They need to explain the test. They need to understand who's getting tested and why. But that test would go off to the lab, just like any other test, and they would come back and your doctor would discuss those results with you. We get a lot of questions about genetic testing, and so just very briefly, when you go to the doctor to ask about genetic testing, they can only use the information for what you want them to use that information for, which is for your own diagnosis. Doesn't mean they can sell it to anybody. There's a lot of very specific laws in place that prevent that from happening. people ask about discrimination based on genetics. And so there is a federal law, the Genetic Information and Non-Discrimination Act, or GINA. This prevents any sort of discrimination in insurance or workplace things from happening on a federal level. But it is really important still to talk to your doctor about this because this law is not perfect. And then in terms of getting covered by insurance, depending on the situation and your situation and your doctor and what they're testing, most should be covered by insurance, but you should always talk to your doctor about what they're testing for and why, and whether or not it will be covered. A lot of places that you probably think of, LabCorp, Quest, all these places do it, so it's actually becoming more and more common. If anyone's done like 23andMe around or something like that, some of these genetic variants actually pop up in those, so you might want to go take a look if you still have access to those things. And then lastly, because I want to get to some questions if we have any. There's a lot of information on one of our websites. It's called the Power Forward campaign. It's just powerforward.com, I believe. Yeah, powerforwardtogether.com, sorry. This is Alonzo Mourning. Does everyone know who Alonzo Mourning is? Everyone's kind of, yeah. Hall of Fame basketball player. He's actually from my hometown. He is, if anyone remembers, he was in the prime of his playing career in Miami and suddenly needed a kidney transplant and had severe kidney disease. They didn't understand why. It turns out this super healthy, super active, very physically imposing man, he had APOL-1 mediated kidney disease, and that's actually what caused his horrible kidney function and horrible kidney decline when he was in his, I believe, mid-30s, so very young and very rapidly progressive. There's also additional resources at the American Kidney Fund and at NephCure, so kidneyfund.org, nephcure.org. We also have some information on our table outside. I might hang out there for a little bit to answer any other questions that we might have. But those are also great places for resources, not just about this kidney disease. They'll also can point you in the direction of clinical trials if that's something that you're interested in as well. And so that's really the main points I wanted to get through. Kidney disease is costly. Some forms of kidney disease can be caused by genetic factors, in particular this one, APOL-1, that we're talking about, and that Vertex is working on very hard to find medicines and treatments for. It can lead to kidney disease. It will not definitely lead, but it is a high risk, and it's important that you understand what your risk is by going to your doctor, looking for symptoms of kidney disease early, and asking about whether or not you are someone who's at risk for this. And then genetic testing can be a thing that should be very helpful. I would say one last piece, because I've said it a couple times, maybe you should go talk to your doctor about whether or not this is something that's important to you or is worthwhile for you. I said the gene was discovered, or this association was discovered in 2010. That's not that long ago. Kidney specialists, kidney doctors, a lot of them are still learning about this. This is very new information. I'll be honest, after hearing this talk, some of you might know more than your primary care doctor about this gene. It's just not a thing that they learned about in medical school. It just was discovered. And so when you go to them and talk about kidney disease and say there's genetic forms of kidney disease I'm worried about, they might not know a lot, and you should ask them about it specifically. And if they don't know, you should say, can you find out more and talk to me about that? Or can you send me to someone who does know? Because this does exist, even if they're not aware of it yet, not their fault, but it's something to think about. Don't let them say genetic kidney disease doesn't exist, that it does, okay? And with that, I think we have a few minutes for questions. I'm sorry to have rushed through that. I feel like I talked a little fast, but if there are any questions, please.
I know you're talking about the genetic, but I wanted to know how blood pressure medicine and what is the first red flag that you have a kidney issue?
The first red flag that you have a kidney issue with blood pressure medicine, or if you have high blood pressure?
No, just in general. That was two parts.
Oh, sure, yeah. So high blood pressure can lead to kidney disease. That high blood pressure can be just harsh on the kidneys and the small arteries there. So if you are someone who has high blood pressure at baseline, you should be at your primary care doctor's office getting your kidney function tests checked regularly. And those tests are that protein and also that blood test to look for your kidney function. The first signs and symptoms are really, it's patients complain of the fatigue and the swelling as sort of the first ones, and the weight gain. That's sort of the typical first signs and symptoms that tend to show up first.
Has there been a study to see why Black people do not proactively educate themselves on this
That's,
and other illnesses?
I'm sure there is a study. That's a very complicated question. I think there are a lot of reasons why education is low across the board. I think there's not a lot of education around this topic in particular. There are reasons why certain populations have not been studied more historically, that information doesn't get disseminated. There's not one good answer, to be honest. I think the only thing I would say is I wouldn't put the blame on people who are not educating themselves. I don't know. I think because of the situation that certain populations find themselves in, we're sort of required to do a little more effort and put in the work to go educate ourselves, where I think it should be on the medical community and doctors and providers to provide that education. But I can't give a very succinct, simple answer for that. But I'm sure it's been studied, and there are reasons.
Okay. I have kidney disease, and I've chosen to do Dr. Sadie alternative holistic stuff, and I've had to research it. Thank God for Beaufort Highway Farmers Market. But anyway, is there a medical place that kind of has holistic alternative options?
I'm not sure. I think they're I don't know the answer to that question. I think diet, exercise, all those things that prevent kidney disease from happening in the first place are all great. I think once you have kidney disease, there are of course medicines that are helpful. It shouldn't be just one or the other, is all I would say about that.
Would you consider the Mediterranean diet helpful in offsetting some of those symptoms that will lead to kidney disease?
I think the Mediterranean diet in general is a sort of healthy one in terms of weight and all of that. So kidney disease can come from a lot of things. So excess weight, high blood pressure, all of those things. So a healthy diet, the Mediterranean diet of which is one, I'd say is a generally healthy diet that is, I would say I wouldn't say it's specific to your kidneys, if that makes sense. It's specific to your overall health, which includes your kidneys.
When you have protein in your urine, how damaging is that to your body?
It's a sign, it's both a sign and a cause of damage to your kidneys in particular. And so I wouldn't think of that protein in your urine being damaging necessarily to your entire body, but think of it more as a sign that something's wrong. You shouldn't be losing that protein in your body. And if you're losing protein that you want to keep, like that's not good because your body needs protein to grow and function. So that's damaging, but think of the protein in your urine as that one of those first signs that something's wrong.
The lady that has take natural herbs for her kidney function, well, I do a liver cleanser once a week, a kidney cleanser once a week, a colon cleanser once a week. And all of my blood work come back perfect. I'm 80 years old. All of my blood work come back perfect. And my blood pressure is always around 117, 118 over 80 or over 78. Pulse rate 56, 64, 77. And I don't have a problem doing the cleanser. So do you think that's a good or bad thing to do?
I mean, you're healthier than I am, so I think I would say that sounds pretty good.
I would advise, I know it worked for me,
Yeah.
but
I think all I would say is that it sounds like you're someone who is very proactive about taking care of themselves.
right, and I don't take any medicine.
Yeah. I don't, yeah.
I don't,
Yeah.
I take that back. I only take Flomax.
Yeah. Like all those things are, I think you take really good care of yourself. And I think all those things are good. They're not harmful. And I think if you are being proactive about your health, then you're going to do well like you did. But I think for people who have very severe kidney disease already or are at risk, being proactive about taking care of your health is good, but also medicines can be helpful too.
The colon cleanser and I take is like a tea. And you better do it as it's directed on the package because it is the truth. Okay? If you do too much, you're gonna run to the bathroom. So, but anyway, my blood work has been perfect for the last, I guess, 80 years. I never go to the doctor I never been laid up in the hospital.
Can decreasing your meat intake improve your kidney function?
Yeah, I think decreased red meat overall is better for your heart health, and everything is connected. If you're someone who has kidney disease, you have to be very careful about your protein intake, and so when you talk about eating meat, that needs to be sort of taken into account. But I think again, it's sort of one of those things where the more careful you are about your diet, the better your kidney health will be. Red meat is by itself isn't bad, but it is I'd be more worried about things like salt and other additional factors. Yeah. Thank you so much.